Good day and welcome back. This is POG STEM Academy. This is a channel where we bring you amazing tutorials in chemistry, physics, mathematics, and general sciences. So the topic before us is expansion in solid. Expansion in solid. So solid, when solids are heated, they either expand or they contract. Solid, they are either, when they are heated, they either expand or they contract. And what is expansion? Expansion is the increase in size and length of a solid. So this will take us to linear expansivity. Linear expansivity. What is linear expansivity? Linear expansivity is the increase in length per unit length per degree of Kelvin rise in temperature. So, and linear expansivity is denoted by the symbol alpha. So anytime we see alpha, it means this is linear expansivity. So, and then alpha now is equal to what? There says increase in length. So when we're talking about increase in length, then we can be talking about the initial length and the final length. When we're talking about increase in length, talk about initial length and final length. So we now says L2 minus L1 all over what? We say L1 into what? Theta 2 minus theta 1. So this is the formula for finding linear expansivity, where alpha is equal to what? Linear expansivity. L2 is equal to what? Final length. L1 is equal to what? Initial length. Theta 2 is equal to what? Final temperature. Theta 1 is equal to what? Initial temperature. So this is the formula for calculating linear expansivity. We have the alpha is the linear expansivity, L2 final temperature, final length, L1 initial length, theta 2 final temperature, then theta 1 initial temperature. So the next thing we'll be looking at is work example. Copper rod whose length 30 degrees centigrade. 30 degrees. A copper rod whose length 30 degrees is 10 meters. Is heated to 50 whose length at 30 degrees centigrade is 10 meters. Is heated to 50 centimeters. Find the new length. Take alpha to be this value. So now we are asked to what? Find the new length, and we know that linear expansivity alpha is equal to what? L2 minus L1 over what? L1 into theta 2 minus theta 1. So and then we are asked to find the new length, and the new length is L2. So now alpha, let's bring out the parameters. Alpha is equal to what? 0.00017. L2 is equal to what? Question mark. That is what we are asked to find. L1 is equal to what? 10 meters. 10 meters. Theta 2 is equal to what? The final temperature, which is equal to 50. Theta 1 is equal to what? Initial temperature, 30. So now from here, we are asked to find L2. To find L2, let's make it the subject of formula. So if we have alpha is equal to L2 minus L1 over L1 into theta 2 minus theta 1. To get our L2, let's make L2 the subject of formula. We use this to multiply by this. I have L2 minus L1 is equal to what? Alpha into what? Multiply by what? L1 into what? Theta 2 minus theta 1. So now, to make this, we now have L2. To make L2 the Sawyer formula, this value will cross equal sign. And when minus L2 cross equal sign becomes plus. When minus L1 cross equal sign becomes plus L1. So we now have alpha L1 into theta 2 minus theta 1. So from here, let's insert our value quickly. So I have L2 now will be equals to what? What is L1? L1 is 10 plus 0.00017 multiplied by what? By 10 into what? 50 minus 30. So which is, I now have L2 is equals to what? 10 plus what? Plus 0.00017 multiplied by what? If I subtract 50 from 50 subtract from 30, I will have 20. 20 times 10, I will have 200. 2000. Let me see. 20 times 10 is 200. So 20 times 10 will give us 200. So now, I now have L2 is equals to what? I have 10 plus. So let me multiply 0.00017 times 200. It will give me 200 point what? I have 0.0000 17 multiplied by 200 is equals to 3.4 times 10 to the power of what? Minus 3. So L2 will be equals to what? So if I add plus 10, it will now give me 10.0034. So meter. So this is our final answer. Of length 15.01 meter is heated until its temperature rises by 60 degrees centigrade. If its new length is 15.05 meter, calculate its linear expansivity. So I will know that we know that linear expansivity alpha is equal to what? L2 minus L1 all over what? L1 into what? Theta 2 minus theta 1. So they say we should calculate linear expansivity alpha. So alpha will be equal to what? What is L1? This is L1. This is the second length, this is the final length. So we have 15.05 minus, this is the initial length. We have 15.01 all over the initial length, 15.01 into what? We are talking about the temperature now. So, but you can see that they say temperature rises. They say temperature rises is what? Is theta. Is 60 degrees. So we know that change in theta, we either write change in theta like this or write theta 2 minus theta 1. So if we are writing it, we write it like this when we have two temperature changes. But we can write it like this when it is only one temperature that was given, the rise in temperature. So here we now have 60 degrees. which is intact. So now alpha will be equals to what? I have 15.05 minus 15.01. When I subtract this from this, I will have, when I subtract 15.05 minus 15.01, I will have 0.04. So now 15.01 multiplied by 60. 15.01 multiplied by 50 will give me 900.6. So now alpha will now be equals to what? 0.04 divided by 900.6. It will give me 4.441 times 10 to the power of what? Minus 5. So what is the unit? The unit is per Kelvin. And that is our final answer.